This was pretty much about solving for unknown angles and trig ratios. One thing you guys need to remember or recall from grade 10 is how to find an angle. And we need to use the second sine, the second cosine, or the second tan button. Okay. So, for example, say if I had a ratio, I'll just show you the first example here. If I had cosine theta is equal to negative 0.5 and I wanted you to find the angle, you would have to go second cosine 0.5. If I want the angle in degrees, what mode do I need to be in? Degree mode. So just be careful, whatever mode you're in, that's the output you're going to get. So if you're in degree mode, you'll get a degree measure. If you are in radian mode, you'll get a radian measure. Okay. Steps for finding the angle measure given a trig ratio go as follows. Step 1, you need to use the CAST rule to figure out which quadrants your solution will be in. Okay, so for your notes, you might just want to put CAST rule here. So depending on if the sign is positive or negative, that's going to tell you what quadrant you're in. Okay, for example, cosine theta is negative 0.5. So we would look at the quadrants. CAST. Do you guys remember what quadrants cosine would be negative in?
4, whatever those two are on the left.
2 and 3. Okay. Step 2, then you're going to find the reference angle. So you're going to go second cosine, and you need to, bless you, this is important, the value you put in is always the absolute value, so it's always the positive value. So if we were doing cosine theta, we would put second cosine 0.5, and you'd get your reference angle. Then thirdly, given that rotation angle, you would apply it in the quadrants that we highlighted from step 1. Okay, so just to repeat those steps, let's check out our first example. But before we do that, let's pay attention to this note guy. So basically what he's telling us is to be aware of the given domain. Here we're either between 0 and 180 degrees, so what quadrants would that be? 1 and 2. Okay, and if we're between 90 and 180, that's just quadrant 2. Okay, or if we're between 0 and 360, that's all 4 quadrants. So you just need to be aware of the domains that they're giving you. So in our first example, we have cosine theta equals negative 0.5. So to figure out what quadrants we're in, we're going to draw the CAST rule. Okay, cosine's positive in quadrant 4 and quadrant 1, and negative in quadrant 2 and quadrant 3. The reference angle, what you're going to put in your calculator, is the second function, and then cosine 0.5. So when we calculate that, what do you get? Did you do it? What do you get? 60 degrees? Okay, so our reference angle is 60 degrees. Third step is we're going to take the quadrants that we found and the reference angle, and we're going to solve for our solutions. So for quadrant 2, I'll just draw a little picture. Okay, I'm going to go back 60 degrees here. That's my reference angle. What we need to solve for is the rotation angle from 0 to that terminal arm. So our calculation will be 180 degrees minus 60 degrees, and we get 120 degrees. So in quadrant 2, our solution is 120 degrees. In quadrant 3, reference angle is 60 degrees. Reference angle is always between the x-axis and the terminal arm. So to figure out our solution, we're going to go from 0 to that terminal arm. Our calculation will be 180 degrees plus 60 degrees. That gives us 240 degrees. So in quadrant 3, our solution is 240 degrees. These would be my solutions for the angles. Okay, and if you're unsure if you got the right answer, all you have to do is plug in cosine 120. So why don't you guys try that? Put cosine 120 into your calculator. Tell me what ratio you get. So cosine 120, you get negative 0.5? Okay, what about if you go cosine 240 degrees? Negative 0.5? Good. Okay, so that's how you could check if you got the right solutions. You make sure that the angle you plug in, the original equation, equals the right-hand side. Okay, sometimes you're going to be given trig ratios that are actually squared. Just note that sine theta squared is the same thing as sine squared theta. We have to solve the equation sine theta squared equals 0.5. But first, we need to just isolate the sign, okay? Whenever you have a trig ratio, make sure it's isolated first. So instead of sine theta all squared equaling 0.5, we want just sine theta. So to get rid of the square, I'm going to square root both sides. And when we square root, we can't forget to take the positive and negative square root. So take the positive and negative square root. Step 1 is to figure out what quadrants will our solution be in. Sine has a ratio of positive and negative square root 0.5. So if we do the CAPS rule, sine is positive in these two quadrants, but sine is negative in these two quadrants. So we're dealing with all four quadrants. Our solution will be in all four quadrants. Step 2, reference angle. Okay, what you're going to put in your calculator is second sine, and you'll get this little symbol here. Okay, sine to the power of negative 1. And then put in the square root of 0.5. Okay, and just recall you're only supposed to put the absolute value, so just the positive value. When you do that, what do we get? 45 degrees? Thank you. Okay, so that's just our reference angle. It's not our full solution. So step 3, we need to find our solutions. So if we're in all four quadrants and I apply my reference angle in quadrant 1 to start, my reference angle is 45. What's my rotation angle? 45. It's equal. So 45 in quadrant 1, that's pretty easy. We didn't have to calculate much. Okay, in quadrant 2, if I apply my reference angle of 45 degrees, I would have to calculate 180 degrees minus 45 degrees. We get 135 degrees. That's the rotation angle. In quadrant 3, we're going to apply our reference angle here, and we need to figure out our rotation angle to that terminal arm. So the calculation will be 180 degrees plus 45 degrees, and we get 225 degrees. And lastly, in quadrant 4, reference angle 45, we're trying to figure out what is that rotation angle. So we're going to go 360 degrees minus 45 degrees, and we get 315 degrees. So our solutions are 315 degrees, 225 degrees, 135 degrees, and 45 degrees. And just to be clear, you're going to make sure that you answer it in a clear manner. So the angle could equal 45 degrees, 135 degrees, 225 degrees, or 315 degrees. Okay, because there's so much going on, if you guys could help me out, just make sure your answers are nice and clear. So rather than dealing with our primary trig ratios, sometimes you're going to be given questions that start with the reciprocal trig ratios. So for example, if we had cotangent of x equals the square root of 3. Okay, do you guys see a button on your calculator that would be for cotangent, secant, or cosecant? No. So we have to change it to an operation that your calculator understands. And those operations are tan, sine, and cosine. So if we have cotangent x equals the square root of 3, we're going to rewrite it in the form tan x equals the reciprocal 1 over root 3. Okay, tan and cotangent are reciprocal functions, so the ratios would be reciprocals as well. Okay, so they've given us the first step for this one. We have cotangent x equals the square root of 3. We're going to rewrite it in terms of tan. And we take the reciprocal of the ratio. And then we start the steps. So what quadrant will tan be positive? Okay, the ratio is positive. So we are in quadrant 1 and 3. That's where our solution will fall. Okay, step 2, we need to find our reference angle. Okay, so x will equal second tan. You're going to put 1 over root 3. Okay, so what's your reference angle? 30? Second tan, 1 over square root 3, 30 degrees, perfect. Making sure you guys are getting the same thing. And then step 3, we need to apply our reference angles in the appropriate quadrants. So in quadrant 1, if our reference angle is 30, our rotation angle is 30. Quadrant 1 is always nice, it's easy. Okay, and then in quadrant 3, if I apply a reference angle of 30 degrees, my rotation angle will be 180 degrees plus 30 degrees, giving me 210 degrees. So x equals 30 degrees and 210 degrees. Okay, next question. Determine the measure of x to the nearest degree. One thing I haven't been focusing on very much, because I've done them and I already know that they're between 0 and 360, but you guys need to be thinking about is what is the domain. Okay, so these examples have all been between 0 and 360, so they've been in all 4 quadrants. The possible quadrants are all 4. Okay, but just keep in mind, if that says 0 to 180, what quadrants are we dealing with? 1 and 2. Okay, so just always be aware of what your domain is. Make sure you're recognizing that, because that could change where your solutions exist. Secant. Okay, what's the reciprocal or the primary trig function for secant? Cosine. Very good. Okay, so we would rewrite this as cosine x equals 1 over negative 1.2631. Now that we've rewritten it, we can just figure out where will our solutions exist. Cosine is negative, so it will exist in quadrants 2 and 3. Okay, let's figure out what our reference angle is. X will equal second cosine 1 over negative 1.2631. What's our reference angle? And in this case, you're probably going to get a decimal that's dragging on a little bit. If we read closely, it says to the nearest degree. So if we could just round the value you got 37 point something, right? Yeah. Okay, round it to the nearest degree. 38, perfect. So our reference angle is 38 degrees. Step step 3, we're going to apply 38 degrees in quadrant 2. And in quadrant 3. Lander, I'm going to get you to help me here. In quadrant 2, I need to calculate this rotation angle. How would I calculate that? Do you know the angle that goes to here along your x-axis? Yeah, 180 goes here. Okay, and then we have a reference angle of 38, so if we went back 38, we could get our rotation angle. So what is 180 degrees minus 38 degrees? Yeah. We can use that answer in the next one, 142. Okay, I'm gonna, because you gave the right answer for the next one, how did you calculate this one? Add them, so 180 degrees plus 38 degrees. What did you get?
218.
We got 218, yeah, okay, just making sure. Okay, excellent. Okay, so if you're in quadrant 2, you're going back from 180, subtracting the reference angle. If you're in quadrant 3, you're going forward, so you gotta add the reference angle. Okay, so our solution would be x equals 142 degrees and 218 degrees. Trying to keep you in the game, Danny. Is that alright?
Yeah.
Okay, just making sure. Okay, these next 2 examples are kind of unique. Because we end up with a reference angle that doesn't actually fall within the quadrant, okay? It's on the axes. So if we have cosine theta equals 0, is 0 a positive or negative?
I don't know.
You don't know? That's an honest answer. It's actually all. It's positive and negative. So if it's positive and negative, and the domain tells us we go between 0 and 360 degrees, then for step 1, thinking about cosine, it can be positive in quadrants 4 and 1. It can be negative in quadrants 2 and 3. So we're looking at all 4 quadrants, because 0 is positive and negative.
In the last one, when I went second cos times 1 over negative 1.2631, I got like 140.
Yeah, we got 142.
More.
We got 142.
No, but you for here, but you got 38.
Oh, I was just listening to something. Oh, did you put negative?
Yes.
Okay, don't put the negative.
Put the negative?
Yeah, you always use the absolute value. There you go.
Okay. So you never put the negative?
No, it's always the absolute value that you put in the brackets. Hey, Emily was just asking about the last one. We were doing second cosine, right?
Yeah.
And we had 1 over negative 1.2631, something like that. I perhaps wrote negative. I can't remember if I did or not, but if I did, I apologize. You only put the absolute value. Okay, you always put the positive value inside the brackets when finding a reference angle. So Emily went ahead, she did that, she got 142. That was calculating a solution in a different quadrant. Okay, so always use the positive one, that will give you the reference angle, then you apply it to each quadrant. Okay,
Thank you.
sorry about that. Okay, going back to example number 5, cosine theta equals 0. 0 is a positive and negative number, so cosine would be positive and negative in all 4 quadrants. Second step, we're going to find our reference angle. Okay, so second cosine 0 will equal that angle, and what do we get? 90 degrees. Okay, so for step 3, let's just do quadrant 1. So if I'm in quadrant 1 here, and I'm going to apply a reference angle of 90 degrees. I'm going from 0 to 90. My solution is 90. Okay, what's going to happen if we're in quadrant 2? Okay, so if I use a reference angle of 90, I'm going back from 180. 180 minus 90 puts me back to a solution of 90 degrees. 180 minus 90 equals 90. Okay, in quadrant 3, I'm going from 180 and I'm using a reference angle of 90. So my calculation would be 180 degrees plus 90 degrees. That puts me at 270 degrees. And lastly, quadrant 4, if I go from 360 degrees and apply my reference angle back 90 degrees, let's put right angles here. Okay, my calculation will be 360 degrees minus 90 degrees. That gives me 270 degrees. So what's the solution? Well, in quadrants 1 and 2, we got 90 degrees. And in quadrants 3 and 4, we got 270 degrees. So we have two solutions that were applied twice. Any questions so far? Cosecant theta is undefined. First of all, let's just review. Cosecant, what is the primary trig ratio for that? Sine. Okay, sine, if we were to draw a triangle and label our sides, what would sine be? What would the ratio be? So, opposite over hypotenuse, so y over r. Which means that cosecant theta would be r over y. When do you guys think there would be ever a situation where a ratio would be undefined? When the bottom's 0? Perfect, when your denominator is 0. So what is being described, I'll just illustrate for you, is say something like this. You have a set of axes, and let's say you have a point that terminates at -1, 0. Okay, there's my terminal arm. What's the x value? We've moved to the left, -1, right? Okay, what's your y value? Is there anything vertical? No, so x is -1, y is 0. What would be the length, the hypotenuse of that line? Or the radius, I should say. From 0 to -1 is 1. So if we plug that into our ratio, we're going to get 1 over 0. That is how cosecant is undefined. Okay, and that doesn't matter, like I could have had the point over here at +1, 0. Okay, my r is still going to be 1. My x is just +1 this time, and my y is still 0. So the ratio would still be 1 over 0. Doesn't matter if it's +1, 0 or -1, 0. That's the scenario when cosecant is undefined. Okay, what would be the case if we had secant theta is undefined? Would the point be over here, over here? So we need what value to be 0? X. Okay, which means it would have to be going down or up. Okay, so just think about that if you ever run into questions where a certain reciprocal function or primary trig function is undefined. Okay, so we have cosecant theta is equal to 1 over 0. That's pretty much our starting point. We need to write this using a primary trig ratio. So we're going to use sine. Sine theta, if I take the reciprocal, will equal 0 over 1. Now is it possible to do this question? Yes. Okay, so for step 1, we need to figure out what quadrants do we fall in. Okay, the domain tells us we're between 0 and 360. Sine theta is equal to 0. We are in all 4 quadrants. So let's calculate our reference angle. Okay, our angle will be equal to second sine 0. And what do we get? We get 0? Nod yes. Nod. You're smiling. I can't see a nod there. Yeah? Good. Okay, so if you go second sine 0, you should get 0 degrees as your reference angle. So now let's see what our solutions will be. In quadrant 1, if I have a reference angle of 0, what's my solution? 0. Okay, in quadrant 2, if I have a reference angle of 0, what's my rotation angle? 180. Okay, in quadrant 3, okay, if I have a reference angle of 0, what's my solution? 180. And quadrant 4, if I have a reference angle of 0, I have to go 360 minus 0. My solution is 360 degrees. So I have 3 solutions. Theta will equal 0 degrees, 180 degrees, and 360 degrees. Okay, had you not known this first part, I really don't think there's any other way that you could solve this question. Okay? If you guys went 1 over sine 0, can you calculate it? So if you put in your calculator, so right now we have cosine, let's say 0, or cosecant 0 degrees. Calculate it, I'd have to go 1 over sine 0 degrees. Is that possible? No, because sine 0 is 0. So that's undefined. Okay, so your solutions shouldn't be possible, if that makes sense. Okay, when you sub it in, it's undefined. For the next little bit, it's pretty much asking the same questions, but instead of solving for degree measures, we're going to be looking at radian measures. Now I'm hearing a few whispers back there. Do you guys actually have questions? Pardon? Do you have? Do you actually have questions? Like
She's just asking who got it.
she's asking if.
We were just figuring this out. We got it.
Oh, you did?
Yeah.
Okay, just making sure. I don't want to be moving on if you guys are a little lost. On this next little bit, I will be going through quickly, so if you do have questions, make sure you're asking, please. For all the examples, we've been solving for our angles in degree measure. If we were to solve this and we wanted radian measures, what could I do with all my answers? Like say I had, one of my answers was 100, I'll just do 120 degrees. Say that's my solution. How could I put that into a radian? What's the calculation? Multiply by?
180.
Close. Pi over 180, yeah. Good. So what do we get there? 2/3 of pi? Yep. What?
Do you have to be in radians?
To do this calculation?
Yeah.
No.
That doesn't matter.
You just go 120 divided by 180. What'd you get? Did you include the pi in your calculation?
Yes.
Okay. So say I didn't use the pi in my calculation, and I went 120 divided by 180, you would get 2/3. Okay, but what Emily did, and that's what I was actually going to get to, so I'm glad you did it. What Emily did was she actually multiplied the pi over 180, and what was the result?
2.094.
With a bunch of decimals?
39510.
Okay. So this is in radians. this is in radians. It's actually the exact same value. If you went 2/3 times pi, you would get 2.094, etc., etc. Okay? Depending on how they want you to answer the question, sometimes they might say, give me the solution in terms of pi. That means your answer needs to have a pi in it. But if they said, give me your solution to the nearest hundredth, then it'd be 2.09. So what if you did go ahead and calculate this value? And then I said, take this value and put it in terms of pi. What would you have to do to the 2.094? Any guesses? If not, I'll just tell you, we divide it by pi. So Emily, because you have it in your calculator, take that value, divide it by pi, and what do you get? 66666. Okay, 0.6 repeated. If you go math track, enter, what do you get? 2/3. My pen's not working anymore. Okay, you get 2/3 pi. Okay, so just depending on when they're asking for in terms of pi or to the nearest hundredth or tenth, etc. Okay, that's how you would do it. So I'm just gonna skip this next little bit, and if you guys could go to page 526, please. We're going to walk through an example a little bit slower just to make sure you guys have it, and then we can call it a day. Okay, the very first example of the day, we looked at cosine theta equals -0.5. That was the very first example we looked at. And we had a domain between 0 and 360. If we went second cosine 0.5, we got a reference angle of 60, and we figured out that our solutions were 120 degrees, 240 degrees. Now, if I wanted, I could convert these to radians, so I could do everything in degrees, and then convert these to radians simply by multiplying these values by pi over 180 degrees. Okay, so we can solve for everything in degrees and then just convert our answer to radians at the end. Okay, and if you do that, 120 degrees converts to 2 pi over 3. We just did that as a class. Okay, and 240, if you multiply that by pi over 180, okay, pretty much 240 divided by 180 gives you a ratio of 4/3 times the pi. Those would be our solutions. Okay, now the only thing that's different is if you say these are your solutions, your domain is now between 0 and 2 pi, not between 0 and 360. Okay, still all 4 quadrants, but 360 was written as 2 pi. Now what if you wanted to start this question in radians? Would anyone want to start this question in radians? Probably not. Okay, you might as well just do it in degree mode, and then if you're asked to solve it in radians, just change it at the end. But say you were, I just want to point out that you would have to change your calculator to radian mode. So just for practice, can you guys change your calculator to radian mode? And this time to find your reference angle, you're still going to do the same procedure. You're going to go second cosine 0.5. Okay, second cosine 0.5. And actually, it's written on the screen here. Second cosine 0.5. You get this value right here, 1.047197551. Everyone get that? Okay, good. So then if you wanted your solution in terms of pi, you would take that answer and divide it by pi. And you'd get 0.3333333.
So when you have a 1.047, is that like saying that with a pi behind it?
That's with pi in it.
Okay. So like that.
Pi is a factor within that number.
Okay, makes sense.
Okay, so the reference angle, if we go second cosine 0.5 from here, that's your reference angle with pi in it.
Okay.
If you want pi outside of it, so in terms of pi, you would have to take the pi out by dividing, You get this fraction of 1 over 3.
So what is this number in?
Pardon?
What is this number in? Like 1/3 what?
1/3 pi radian. Okay, so our reference angle is 1/3 of pi, or we can write it as pi over 3. Okay, which is equivalent to 60 degrees, by the way. Okay, so we found up here, second cosine 0.5, our reference angle is 60 degrees. Pi over 3 is 60 degrees. Okay, so we still have the same reference angle. If you were to ask to solve for this in radians, the only thing that would be different, here quadrants were 2 and 3. In quadrant 2, okay, what is this value? 180 in radians would be just pi. So our calculation would be pi minus our reference angle, pi over 3. Pi minus pi over 3, if we give ourselves a common denominator, would be 3 pi minus 1 pi is 2 pi over our denominator 3. Okay, and if we converted this back to degrees, we would get that 120 degrees we started with. Okay, so this is just solving in radians versus solving in degrees. The steps are no different. We first figure out the quadrants that the solution will be in, then we find the reference angle, and then we apply the reference angle in that specific quadrant. So we found a solution in quadrant 2 as 2 pi over 3. Okay, now if we need to solve for the solution in quadrant 3, my reference angle is pi over 3. This little, or this marker on the x-axis is 180 degrees, or pi. So our calculation would be pi plus the reference angle to give us this rotation angle. So pi plus pi over 3, give yourself a common denominator, would be 3 pi plus pi is 4 pi over our common denominator 3. And say you solved it in radians and you wanted to go back to degrees, what would we have to multiply by to get back? You got it. So you just multiply by 180 over pi. Pi's would cancel out. And we get 240 degrees. Okay, so that's if you had to go back to degrees. I know we've done a ton of examples of using degrees to start. If you guys had to take a vote, who would like to do questions like this just in degrees, and then if you're asked to solve for radians, convert after? I know I would. But it's up to you guys. If you like using radians and the pi symbol, then that's okay. Totally okay. The rest of the examples are pretty much the same steps. I'm going to get one volunteer to come on up though, and we're going to see how we do. Okay, the volunteer is simply going to be writing on the board. The class is going to be telling that recorder what to do. You're going to write?
Sure.
Okay, come on down.
You don't have to think.
So, let's take a vote. A, B, or C?
That was bad.
A, okay. We only had one person contribute, so we're doing A. Now, the domain is between 0 and 2 pi. What quadrants can we possibly be in? All 4. Good. Now, do you guys want to solve in degrees or radians?
Degrees.
Okay, degrees. So right away, I'm going to help you guys out. Let's just put our domain 360 degrees, because we're going to give our answer in degrees, okay? All right, you guys got to help Emily.
You're going to be on camera.
Yay! First step, help her out.
Cat.
Should write your first
What?
step. Okay.
Well, we're just doing A, so she can write wherever she wants.
Okay, we're doing A or B?
A.
Oh, I thought we were doing B.
You guys got to help her.
No, other way.
This way?
Yeah,
No.
see there, yeah.
Yay, good job.
No, you
Okay.
don't get the circle.
I wanted to.
But you don't need to.
Wait, we
Just
don't
gotta
do all?
Top two. One and two.
Chris, why just 1 and 2 though?
Oh,
It's a
'cause it's
it's a
sin.
positive number and that's where sin's positive.
I was trying to trick you, Chris.
Okay, good. Sin is a positive ratio, and sine is only positive in quadrant 1 and quadrant 2. Okay, you guys gotta help Emily here. She's just writing down what you're telling her.
Literally it's just two.
What are you laughing at?
So solving for the reference angle, good. How is she gonna calculate the reference angle? Hands up.
Joe? Actually, Jared.
Second sign, 1/2.
Good. Second sign. I'm gonna use the absolute value, 1/2. Awesome.
What is that?
30 degrees.
Okay, who knows the next step? Hands up.
Jared.
Well, in quadrant 2, it's going to be 180 minus 30. It's going to be 150 degrees.
Whoa, whoa.
So starting in quadrant 2,
Good job.
Jared, I'll let you say it again.
180 minus 30. That's your rotation angle.
So 180 degrees minus your reference angle. And Jared's telling us that gives us the rotation angle. Good job.
And in quadrant 1 is just your reference angle to rotation angle.
Emily, what did Jared just say?
In quadrant 1, reference angle is the reference angle?
Perfect. Just making sure the camera can hear it.
Oh, my bad.
Good job. Awesome. So we got our two solutions, 150 and 30 degrees. Oh, but this question was asking for a domain in radians. How's Emily going to get that into radians?
Multiply.
One at a time. You're so excited. Okay, and let's say I want your answers in terms of pi. Okay, help Emily out. 5, 6, 5. Good. What's the other one?
1 6.
Is it 5?
That's fine. So you're right.
What's this one?
Good. Pi over 6. Awesome. Good job,
Just clap
team.
for me.
So,